forward to Ben via his EA. And I also want to recognize a few people, our mentors, who's been wonderful in coaching our teams. And today we have Stu here, we have Kane, and we have Brian, and I don't know if Oscar is still with us, but we also have Jeff, who's our mentor last quarter. And then for the teams who got to travel, we have Sean from CMP, so please give a big hand. Sing now, please sing. Keep your way.
All right, everybody, thank you for being here. We're going to go ahead and get started with the presentations. So let me just pull this up, and it should be, oh, excuse me. All right, so up first, we have Team Delphinus, and we're going to play their video.
Hi everyone, we are Team Delphinus, an i4NS team comprised of entirely grad students. We are given the challenging topic of maritime domain awareness around the waters of Taiwan. However, we are not entirely familiar with lots of aspects surrounding the country, especially its geopolitical landscape. The team relies significantly on our problem sponsor, Pingwan, for ideas and potential statements. Our team has a strong background in marine biology with 2 PhD students who are knowledgeable in ocean science and acoustics, with only 3 members who all have extensive commitments outside of class. We reorganize and push forward with the course. We are very grateful to the teaching staff and our problem sponsor for all the positive support and encouragement.
By week 2, we arrived at our very first mission model campus. At this point, our work revolved heavily around our problem sponsor, Pingwan. We listed his think tank group as a key partner along with INDSR, or the Institute for National Defense and Security Research, and the Taiwan Coast Guard as the main beneficiaries.
Since we weren't sure what to focus on at first, we got our bearings by exploring 3 major MDA challenges for Taiwan. The first is anomaly detection. By understanding abnormalities from normal patterns, Taiwan can identify suspicious activities and respond quickly. Another MDA challenge is submarine cable sabotage. Submarine cables play a vital role in global communications, and the intentional severance of these cables can result in communication outages and costly repairs. Finally, infringements on Taiwan's exclusive economic zone undermine its ability to protect its national interests. As the border wore on and our interests developed, our team developed a problem statement that merges the first of these 2, anomaly detection and submarine cable sabotage.
All right, come on up, Team Delphinus.
Hi everyone, we are Team Delphinus, an i4NS team comprised of entirely grad students.
Alright, howdy everyone, we are Team Delphinus. Over the course of this quarter, we completed over 27 interviews where we learned a lot from various people that could be involved with this project. Our initial problem statement was simply to develop a system to monitor ocean conditions as well as sense and potentially counter incursions. But that's evolved into a final problem statement to flag possible incursions on submarine cables off of northeastern Taiwan. And our tool of choice for this task is passive acoustic detection with real-time processing. My name is Aaron. I'm an oceanographer and PhD student. So basically, I'm doing a lot of what Ben did during his school years, but in a much larger lake.
Hi, my name is Anabel Espinosa. I'm a fisheries biologist. I'm a PhD student on my first year as well.
Hi everyone, my name is Namfam. I am a master's student with the Data Science Online at UCSD. My role, I'm mainly involved with research and administration, and our problem sponsor is Pingwan over there. So our original minimum viable product revolves around a unmanned underwater drone called the Remus 620. So produced by HII, this drone has amazing capabilities. It can hibernate between hibernation and active phase. So it can navigate itself to an area of interest where it will carry out its task. Either be a video capturing or sensor or measuring certain things, and then can navigate back to its original location. From then it will be a dealer to this powered buoy where it will unload its data, and the buoy will then transmit this data with satellite communication to the interested party, the end user, and our fiber optic operators. However, at $1 million, the drones are not viable at scale.
So for final MVP, we decided to do an array of acoustic sensors along the submarine cable. This will be the first phase, which will allow us to hear and what is going on and be able to detect anomalies, like for example, ships running their anchor or ships slowing down. And then this hydrophone will have real-time processing data, and the data will be jettisoned to the surface. So then it can send a ping and saying that an anomaly is happening here, and then the following steps will be to find a way to connect the hydrophone to the cables, so the communication can be through the cables, so it's faster. So our final version of our mission model canvas, we have our beneficiaries who will be the telecom companies and also the submarine cable operation and logistics. And the value propositions is to monitor underwater cables in northeastern Taiwan, and allowing to refine the ability to investigate any anomaly that may be happening. And one of the things that's important is that this monitoring tech is quite cheap compared to the cost of the cables. For us to be able to do this, we need to have key partners like the Taiwan Coast Guard, the United States Coast Guard, and the submarine cable operators.
All right, so just to kind of reiterate where we come from. Stand in the middle. Will do. So where we've come from and where we are now, we started out with this initial objective just to advance Taiwanese maritime domain awareness without much of a very clear goal as to what we do within that. And where we've ended is a final objective of monitoring submarine cable infrastructure. Through that, we've explored a lot of different venues for how we could understand the maritime environment. We've looked into drone tech. We've looked into fiber optic monitoring, basically using fiber optic cables themselves to do the anomaly sensing. And we've arrived at this basically a conclusion that what we want to use to monitor these cables is real-time passive acoustic detection. Processing passive acoustic data in real time and detecting anomalies from that data stream. So in terms of our investment readiness, our interviews and our interactions with potential users over the course of this quarter have suggested that this project is really promising. Our interviews with U.S. military affiliated members have suggested that there's a lot of interest in this concept. We still need to communicate with telecom companies themselves who are operating the cables to find out if they would be interested in participating in integration of our technology and our interests with the cables themselves. Our own interest is still kind of up in the air. We're all grad students, so we are balancing this project with our existing duties that come with that. But we're definitely very interested in continuing this work. Quick shout out to our mentors, Ping and Scott, who've given us so much feedback and done such a great job leading us through this project. Also to our teaching team, Rachel, Kristen, Hannah, and Diana. And then finally, these are all the interviewees who we got to learn from over the course of this quarter with so many different interviews and discussions that led us to a new idea at every term. And that's it for us. Thank you.
All right, next up we have Team Athena.
Hello, we're Team Athena, and we're comprised of 6 students here at UCSD that are part of the Innovating for National Security program. At the beginning of this 10-week program, we were given a problem statement, and our statement was, how can we create a solution to help Ukraine combat the drones in the Ukraine-Russian war? We were first tasked to create an MVP without all the initial interviews that were required, other than with our problem sponsor. And so our MVP reflected our initial assumptions of what we thought the main problem in the conflict was. And so our team realized that in order to hone in on our MVP, we're going to have to be conducting many more interviews. And so throughout the following weeks, our team conducted interviews with drone experts, geopolitical experts, as well as even Ukrainian soldiers who fought on the front lines. And throughout all these interviews, a roadblock became clear, and it was that our problem was continuously changing. Because of the continuous development and innovation on the battlefield, Ukrainian soldiers who have been off the front lines for a couple of months already have out-of-date information. We realized that to get real up-to-date information, we'd either have to go in person or get as close as possible in person to talk with Ukrainian soldiers who have up-to-date information about the current battlefield. And so, with Common Mission Project support, 3 of our team members traveled to Estonia to attend 3 conferences with the topics being defense and innovation. At one of these 3 conferences, specifically the Estonian Defense Meetup, we were able to interview our users, that being Ukrainian soldiers who were fighting on the front lines. One specific Ukrainian soldier was there specifically to present about drone defense and air defense in the Ukrainian airspace. During our interview with the Ukrainian soldier, we asked for feedback about our MVP as well as receive validation on our MVP. And with our MVP finalized, our problem sponsor gave us the closing remarks of the possibility of us continuing our MVP as well as keeping in mind the technological aspects of our MVP. Although we did not have time to hone in on the technical aspects of our MVP, we are thrilled to present to you all our process and final deliverables for our project. Thank you. Hello.
Hello, we are Team Athena, and the task that we were originally assigned to was to devise a solution for FPV and Shahed drone interception and mitigation, and at this point, after 10 weeks with this cohort, we have completed 90 interviews. So my name is Giselle.
My name is Jeffrey.
I'm Dylan.
My name is Catherine.
I'm Megan.
And I'm Nathan.
So how did we start tackling our problem statement at the beginning of this project? As you can see here, this is our very first mission model canvas, and at the start there are definitely a few unknowns, just because we hadn't yet been able to conduct interviews and get a much deeper understanding and sense of the problem itself. And then as the weeks progressed, you can see that our MVP developed a few different times and transitioned between ideas in reflection of the different insights we gained, as well as different patterns in terms of what pain points were brought up by most of the interviewees over that course of time. And so after conducting all those interviews and just more research on the project as a whole, to better understand our problem statement, this is our final mission model canvas. As you can see, it's much more fully fleshed out than it was at the start. We have a few specifics in mind in terms of the cost and deployment, and our value proposition and problem statement as a whole is much more refined in the sense that we know, right, who would benefit from our solution, that being the frontline soldier and military commanders in Ukraine, and we have an idea of how that technology works and how it could be deployed.
So what exactly are we addressing? At this point, our problem statement had gotten a lot more narrowed down and we started focusing on FPV drones. From the initial assumptions that we had, we thought that the big problem had to do with intercepting the drones, but after we had more conversations with frontline soldiers, we realized that the big issue was with actually being able to detect distance. Right now, Ukraine is able to visually detect incoming FPV drones, but they can't control necessarily the numbers on how far the FPV is, and so if we can provide them with a detection system, it'll be a lot easier for them to have accurate interception.
So with that problem being said, what solution did we come up with? Well, our solution, or our MVP, is a multi-sensor detection system that uses RF and acoustic custom sensors that are fiber optically connected that carry and drop sensors throughout the battlefield using an FPV drone. So now let's get into specifics. So first we have the acoustic sensor, which operates with these features and these potential issues. Then we have the RF sensor, which has those features and issues. The reason why both have to be omnidirectional is because as we're on the battlefield and we're dropping these sensors, we want it to be able to detect no matter how we drop it. So for instance, if we had something where it had to face a certain direction and we dropped it, it might flip over and that wouldn't work.
So a key point that we were thinking about is who benefits from this, and this comes back to our beneficiaries. The entire value and use of our product centers around our beneficiaries, which are the Ukrainian frontline fighters and the military command. Both of these beneficiaries have a highly vested interest in keeping frontline fighters alive and capable of mitigating Russian attacks, specifically in our case to do with Russian drone attacks. With us, our product seeks to fulfill their needs of a practical solution for detecting and disabling FPV drones and an effective counter for our enemy FPV drones to protect soldiers and friendly FPV pilots.
All right, on the battlefield, Ukraine and Russia maintain a zero line, 200 to 300 meters apart, leaving a disputed land in between. The zero line is basically the edge of secure land, secure territory, and our solution basically drops RF and acoustic sensors throughout the battlefield, and these sensors detect incoming enemy drones, allowing Ukraine forces to send FPV interceptors and allows them to use firearms to shoot them down.
Yeah, now that we understand the context, how do we move forward with research and development? So, research and development is going to 3 big steps: gathering materials, developing product, and testing the actual product. And there's associated cost and timeline for those 3 steps as well. Now, here's a breakdown of the cost for the products that we're suggesting. A custom-built acoustic sensor and radio frequency sensor that has the various components and the commercial prices listed on the right side of that, with the acoustic sensor having a range of detecting drones from about 100 to 300 meters, and the RF sensor having a detection range of about 500 to 1,000 meters. Now, looking specifically at the acoustic sensor, some of the key components we want to take part in is that there's an omnidirectional mic, it has acoustic vents to be weatherproof, and it also uses an analog digital converter. And then for the RF sensor, some of the special components include the software-defined radio, the omnidirectional antenna, as well as the embedded controller.
Okay, so what has our journey been like? So here's our project timeline. As you can see here, we're only at the end of our first start of our timeline. Now what that means is during i4NS, we were able to conduct a lot of interviews. We learned a lot about how you develop a problem statement. As you can see from our video at the very beginning, you don't really know anything. You need to do the interviews, and like what Ben said, you need to understand the pain points of the users that you're trying to create the solution for. Afterwards, we're going to get into concept and design. Then we're going to focus on R&D, which we've done a little research for, but obviously we need to do even more interviews in the industry to understand. Iteration and final implementation, which is testing, as well as getting our MVP onto the actual battlefield and actually testing to see if it'll actually work.
So looking forward, we're going to be looking for more feedback from Ukraine forces and looking for builders to develop our solution. And these are some photos of our interviews. And we want to thank Rachel, Ping, and our TAs. And then more photos of our team. And then a rough overview of our solution. Thank you.
Hello everyone, we are Team Redstone and we are working with our problem sponsor Thomas Forsyth, a civil engineer from the 9/11 Airlift Wing and based in Pittsburgh. Originally, civil engineers at the base were faced with an issue, a mandate requiring them to integrate new electrical technology into their buildings that were not made to handle such modern tech to meet sustainability standards. However, in our journey, our problem statement took some sharp turns, especially since the mandate had been lifted. From early interviews, notably with a mechanical engineer, we discovered several key performance indicators they valued were energy independence, resilience, and cost effectiveness, but not sustainability.
Getting the opportunity to go on the base in Pittsburgh, we interviewed a few more key beneficiaries, a mission support group commander who oversees mission readiness, and a base civil engineer, who highlighted issues with the existing base system such as unreliable generators. It was clear that the base suffered from power outages that impacted their productivity and mission readiness. With the insights we gained from our interviews, we developed a Pew matrix to compare different backup energy options. Based on our research, we created our MVP as a modular BESS system, designed to keep critical loads online during grid outages.
Our initial idea was for each building to have its own battery, but further research suggested that we need something with more power, something that had mobile capabilities, and something that needs to be able to act fast to adapt to on or off base issues really quickly. So looking at our final MVP, our solution provides immediate access to energy and integrates smart systems to expedite the base's response time.
In order to achieve these key functionalities, we are proposing that the base should adopt a BES system with 5 key components. 1, the actual battery that will store and release energy upon need, a battery management system to monitor battery performance, an inverter, automatic switch gears, and an energy management system to control everything.
Looking forward, we will validate technical specifications and incorporate feedback into our solution. Because the implementation will be handled by the base engineers who will identify their mission-critical buildings and which buildings specifically need that implementation, we will provide them with multiple scalable solutions and vendors with as much information and specification as possible.
Hi everyone, we are Team Redstone, one of the teams in collaboration with the 9/11 Airlift Wing in Pittsburgh. And my name is Minju. I'm joined here with Iman, Weifeng, Gilad, and Dave. And so what's interesting about our problem statement journey especially is that we had a huge change. So as I said in the video, we initially focused on integrating new electrical technology into the base because of a mandate, but because through our process, we instead prioritize resilience, efficiency, and energy independence during power outages. But how exactly did we get here? So, a big problem, some of our big blockers during our journey was that the electrification mandate was lifted, so the driving force behind our problem statement had vanished, and also we had some trouble establishing connections with our problem sponsor and contacts on the base. And so we initially tried to keep going with our original problem statement, but as we conducted more interviews, we realized that our end users were really worried about energy resilience and efficiency in the face of power outages. And that's how we got to our final problem statement. And so we actually had the opportunity to tour the base in Pittsburgh, and we got some really amazing key insights and diagrams from our sponsors, commanders, officers, and engineers. One of the most important diagrams we got was the actual base layout, where we learned that there's a central substation that powers the entire base, and that it also feeds off of 2 external substations from the Duquesne Light Company. And we also learned that the critical loads, or the most important mission critical buildings, are located near the north side of the base. And we also learned about the available land for construction, and there is very little. And we also got the inside scoop on the utility feed diagram. This diagram right here, all it's really showing is that there are two energy sources. One is the main grid utility, and the G stands for generator, and you can switch between the two using a mag switch, and the panel distributes the energy to the rest of the buildings. So we had a lot of twists and turns initially, but eventually we got to a buffer system between the main grid and the energy, the generators.
So this is the first version of our mission model canvas, which emphasizes, we have a long list of different beneficiaries for our first mission model canvas. We also explored a potential relationship with the Pittsburgh airport. For our updated MMC, we reduced the amount of beneficiaries to focus on 2. We also edited the value propositions to emphasize energy resilience as well as mission readiness. So here is our updated MMC. Here is a diagram that shows some of the different ways that power outages can affect base operations. So for example, an outage can affect the UTA training weekends as well as flight prep. And here are the effects color-coded to the different beneficiaries. So our first beneficiary was a mission support group commander, and his job is to ensure mission readiness. This is difficult in case of a power outage because power outages can result in mission cancellations, which in turn can affect base funding. And our solution will provide reliable energy to prevent future mission cancellations. And our second beneficiary is a base civil engineer, and his job is to monitor and maintain the base infrastructure. So our solution will be easy to maintain and easy to implement.
Alright, so going into the MVP evolution, some of the initial questions we were asking were like, how can we restore backup power? How might we prioritize critical loads? And so our initial plan was looking at it at a building level, installing wall batteries on every building. But then we realized really quickly through further research that we might need more power to meet the demand. And so we looked at bigger batteries. Yay! We have enough storage for all this power. But one of the unexpected roadblocks we encountered was funding. And so for construction level funding for military bases, the timelines are longer and the funding is more selective. So how might we work around this issue, even if we get the funding? So we decided to work closely with our problem sponsor to figure out a way to bypass this limitation. And this is through a technicality. So you see the word mobile. So there's two types of funding to keep in mind. There's construction level funding, which is anything that's permanently bolted down on the base. But there's also operational funding, which is anything that's not physically attached permanently. So we're opting to add wheels as a way to make it non-fixed funding, which allows for faster funding. And then we also took it a step further. Now that we have an acquisition plan secured, we also looked into the workflows themselves. So we looked at our outage protocols and noticed a lot of manual steps and interventions needed before they are able to dispatch people. So we thought of looking into an EMS as well. And then looking into our final MVP, there are 4 key capabilities to keep in mind. So let's look at Black Start. So Black Start is basically the instant access to energy. This is really crucial when you don't know how severe an outage issue is or how long it will last. And then secondly, we look into EMS for addressing some of the automation opportunities there.
And so the other 2 components of resilience and modularity, one are really technical capabilities, more so general themes that were heavily emphasized throughout the project. So in terms of resilience, obviously you don't want your backup power system to go out easily, so it looks like being able to resist the weather and the storms that they have there, being somewhat protected from physical contact, as well as being internally regulated, whether it's heating or overloading. And then modularity, this was more so that the base could adjust to their needs. Within the context of our project, we serve more as system integrators rather than innovators, and so it was a big focus for them, or it was a big demand from them that they wanted to handle implementation. So our solution is very easily adjustable depending on their energy needs. So what does this actually look like? The BESS we propose has 5 key components. 1, the actual battery, and then within that container you have the BMS, battery management system, that provides key information like state of charge, state of health, support and safety like cooling and fire suppression, an inverter that basically converts your current into the type of current you need, whether it's buildings using alternating current or the storage being direct current, and then the EMS for you to gain not only just control the flow of energy from the battery to the buildings, but also gain more visibility in terms of if we have an internal power outage, where exactly is the problem, and that allows us to save some time in correcting that. So just a rough high-level diagram of how this might be connected. Our solution really is just supposed to be a turnkey solution, meaning minimal changes to existing infrastructure. So we're kind of just putting the batteries in open space, and that battery should just be able to connect to the existing ports that they have across different buildings. Now, tying back to our original problem statement about sustainability, this is really good because it provides sort of a foundation for you to implement a future microgrid or solar panels in the future, because you need batteries for those as well.
Alright, so now that we've figured out a battery solution, what does a potential deployment diagram look like, and where do we come in? Well, basically, after we finalize all the specs and the constraints, and after we understand all the vendors that we need, that is basically where we end. After that, we give our solution to the base engineers, and they focus on finalization, installing, and then testing. So, exactly what does, how do we impact, how does our solution impact the base? Basically, during UTA training weekends, we have, the base has an influx of a lot of people, and as a result, they need funding to train soldiers, and during the 4-hour training segment, when there's an outage, $220,000 of productivity hours is lost as a result. And our solution will prevent that from happening. So looking forward, our next steps are very simple. All we need to do is basically verify all the vendors, all the technical specifications, and really draft our technical white paper to present to the base and the base of engineers. We'd like to thank our teaching staff, our problem sponsors, and our mentors who are here in the audience somewhere. This is what our journey looked like. We'd like to thank all of our interviewers who came, and basically that's it.
All right, thank you guys. Up next, we have Team Resilient.
Hey, good evening everyone. We are Team Resilient, and this is our mission. The 9th 11th Airlift Wing's base civil engineering unit is actively pushing to strengthen base energy resilience and prevent mission degradation during outages. Our mission is clear: support the 9th 11th Air Wing in Pittsburgh by delivering solutions that ensure uninterrupted operation and sustain energy resilience when the grid goes down.
When we started, we thought the solution would involve renewables, possibly a solar-based system or battery storage. But as we dug deeper, we realized that the real issue wasn't just about sustainability. It was about mission-critical continuity and the need for rapid, reliable backup.
The base receives energy from a single utility feed, so if an outage hits, even briefly, the entire base is affected, leading to mission delays, safety risks, and losses of up to $33,000 per instance.
After 20 interviews with military engineers, base staff, and academic scholars, we discovered a deeper problem. There is no fast or reliable backup system in place that aligns with military processes, infrastructure constraints, and weather risks.
So we developed our final MVP, a distributed diesel generator system. This design includes a primary diesel generator at the main substation, plus mobile units stationed at critical infrastructure points. It buys time, ensures continuity, avoids permanent construction, and requires no extra manpower.
Looking ahead, our goal is full implementation within 2 years, as well as reaching out to more bases. Our system is cost-conscious, scalable, and UFC compliant. Thank you for the opportunity to work on such a meaningful challenge, and we hope you enjoy our presentation.
Ladies and gentlemen, good evening. We are Team Resilient, and over the course of the last 10 weeks, we conducted about 34 interviews, and we conducted this with base personnel, DoD personnel, as well as individuals from research laboratories and the university itself. So really to begin, our original problem statement was we're trying to limit emission degradation during power outages and to improve base resiliency. Because the base itself seemed to lack what's called stable alternative power supply. For us, during this time frame, the problem statement was quite broad. So over time and over more interviews, we condensed it down to be much more specific. What we condensed it down to was fixing the main backup power system. So really to provide context what BASE does, the BASE is primarily targeted towards providing C-17 operations. And the BASE situation is that they receive a single utility power from what's called a utility company, and this creates a single point of failure. What that means is that if there is any sort of issue, such as a cyber attack, or maybe it's called physical failure, or potentially weather, then that means the entire base is affected. What we wanted to do was find an energy solution for the base that was simple, sustainable, and affordable.
So just to give a very simplified outline of the sort of protocol the base undergoes and our proposed protocol for comparison. When a blackout happens, the power goes out and a lot of internal communications have to occur with civil engineers on base, and that takes roughly an hour, and then they have to figure out whether or not it's an issue on base or it's an issue with the light company, the main provider, and then calling the light company and then sending an electrician takes roughly 2 more hours for a total time of 3 hours. And the big issue with this is that base operations are completely off during this time, being on very busy weekends and upwards of $33,000 in projected loss. Sorry, twice. And our proposed protocol is that after the power goes out, the backup generators kick in and reduces the time that the power is off significantly and saving the base a bunch of money and productivity.
So this is our original mission model canvas from week 2, and as you can see, there's a lot in the value proposition. Well, there's a lot in the whole canvas, so we have a lot of honing down to do, especially in the value propositions and the beneficiaries. At this point in time, we also were unaware of any possible budget restrictions or impact factors. And this is our current mission model canvas. Our narrowed down value propositions include providing an uninterrupted power source to the base, as well as compliance with local law. And our beneficiaries include Edward, who's the Mission Sustainment Director, as well as Jacob, who's an Electrical Engineering Manager. And at this point in time, through interviews and things like that, we know that there's actually no budget restriction, and the base is willing to spend if our solution is viable. But obviously, being within a reasonable budget is always helpful. And our mission will be successful if we're able to provide a resilient solution that can give uninterrupted power during emergencies.
So this is our beneficiaries in more detail. So meet Edward, the Mission Sustainment Director. His responsibilities include base infrastructure readiness, coordinating leadership, but he's constrained by military procurement protocols. So to get his buy-in, we must buy time and guarantee continuity without permanent infrastructure. And on the left is Jacob, the Electrical Engineering Manager. He's focused on continuous energy delivery, legal compliance, and maintenance. His buy-in depends on a solution he can set and sustain with minimal stress on manpower and no surprise compliance risks. So together, their approval is crucial to implementation and sustainability. So this diagram shows key players influencing our project's success. On top is desirability with our users at forefront. For buy-in, we have Scott Howard, the problem sponsor, who prioritized ease of implementation and mission continuity, and Robert Barbish, the chief of engineering, who ensured technical feasibility. For advocates, we have a viability side, who provided practical insights into everyday operations, and feasibility side, who made sure our solution was code compliant, modular, and aligned with DoD processes. And then lastly, for the saboteur, we have the City of Pittsburgh utility guidelines, which made us rethink our MVP, which led us to focus on distributed diesel generators, which preserved compliance and function.
Alright, so for our MVP, we started out trying to go for renewable energy sources. So first thought was solar. After going and touring the base and conducting interviews with more professionals that were there, this was not a viable solution. So we started looking more towards gas and distributed generators and eventually ended up with distributed diesel generators as our main MVP. Yeah, on this base visit, huge thank you to Scott Howard for setting it up and Tom Forsyth for showing us around and to Common Mission Project for funding it. For our final MVP, what we've decided to propose is this being their primary substation. We want to connect some battery or some generators directly to that to feed power through the rest of the base, just on a very low level, enough to power lights and maybe some computers. And then have some other additional generators that can be moved around that would be able to power on a building by building basis. This is the exact one that we're looking at, the CAT XQ-Key30, which would fit the power requirements per building.
So for our team actionables, we divided it into 4 steps, and we're currently on our first one where we are verifying our solution with problem sponsors and base leadership, and are so far hearing good feedback on our MVP. Additionally, moving forward, we're going to be looking at supplier research and on our generators to look at the cost analysis and also creating a proposal on the viability of it specific to the 9/11 airlift base. Finally, something that we want to highlight in our 4th step is doing additional research on renewable energy resources. While this solution that we have right now might solve today's issue, we also want to consider how it might change in the future. And with that said, we would like to thank everyone and part of this program. The last 10 weeks has been very enriching for us. Special thank you to Scott Howard and Robert Barbish for our problem, the opportunity to work on a real-world situation. Additionally, our mentor Liz for her incredible insight, and the teaching team, Rachel, Kristen, Hannah, and of course our TA Diana for their support and mentorship as well. Thank you. All right, thank you guys. And last but certainly not least, we have Team No Smoke.
Hi, we're Team No Smoke, a team working with the U.S. Army through UCSD's Innovating for National Security program to investigate a long-standing fire suppression issue in the Abrams M1A2 Set V2 and V3 tanks. I'm Andrew, technical lead and developer.
My name is Sally, the project manager and designer of this group.
I'm Sabina and I handle our technical documentation.
I'm Thunder, the team designated researcher.
I'm Zane and I lead interview outreach and coordination. For some context, fire suppression systems on Abrams tanks operate using fire sensors to automatically deploy chemical agents in the event of a fire. However, the system has been malfunctioning for some reason, deploying the gas without a fire present. This has cost thousands in wasted bottles, disabled tanks, and disrupted missions.
Initially, we suspected that the root of the problem was a failing slip ring, possibly degrading and misfiring signals. But with only anecdotal evidence to go off of, we couldn't confirm it. However, during our research process, we found fragmented and informal methods of data collection. Tank units were not collecting standardized reports. Some utilized group chats, while others used paper.
We realized no one could learn from what wasn't being tracked, so we pivoted.
Instead of guessing the cause, we focused on designing a structured, field-ready system to collect standardized incident data across units.
Our system has 2 parts. The first is a secure mobile app for crews and maintainers to log each misfire with key details: location, sensor ID, and human notes. That data is uploaded to a central repository. The second is an updated tank interface that shows real-time system data.
Together, they create a reliable, centralized data set for diagnostics and future fixes.
It enables faster repairs, safer missions, and smarter decision-making.
We're Team No Smoke, and our mission is simple. Build the tools that make what's complicated easier to keep tanks operational for longer.
All come on up, Team Listener.
Hey everybody, we're Team No Smoke, part of the i4NS program here at UC San Diego. And over the last 10 weeks, we've been diving deep into why fire suppression systems are causing false issues. Our mission was to get to the bottom of this issue. So we've interviewed 50 people from the US Army to figure out why this is happening. So before we dive deeper, I'd like to introduce you to our team. So my name is Zane.
I'm Andrew.
I'm Sabine.
I'm Thunder.
I'm Sally.
Yeah, so for a little bit of context as to how a fire suppression system actually works, it uses a two-shot system. So the first shot is actually triggered automatically if the sensor detects a fire. Now, if this shot doesn't work, then a second shot can be shot manually. In normal situations, the crew would usually exit, and then the crew would usually exit. And after that, it'd be 4 to 10 hours depending on the compartment. The operational capacity of D4 will also be 50% per disactivation.
So we began with a clear mission: identify the root cause of these errors and fix them. Our initial mission model canvas was structured around the idea that we would be finding the root cause and replacing the hardware. However, we had to find out what was really happening first. As we began our interviews, we received conflicting information, accounts were not consistent, and further, there was no standardized collection or storage of this data. There's too many factors and not enough data, so we pivoted. Our new initial MVP idea is a data collection system that would take information about the tanks and about the incidents that the tanks are experiencing and add them to a centralized data set for future use.
This is our second mission model canvas, and we just adjusted it to reflect our initial MVP. We conducted 30 interviews on base in Germany, and with that feedback, we refined our MVP. Initially, we believed that our MVP would be beneficial to everyone because we believe that the data would provide clear data insights to improve decision making. But after conducting our interviews, we realized that the person that would benefit the most would be the maintainers, because this would be impacting them directly, since it would be impacting their workflow and minimizing the amount of guesswork they have to do to find the cause of the issue. And then therefore, since it minimizes the guesswork, then it would help have the tanks be mission ready faster, and it would help the operators and high-level leadership as well. And then we also learned that the tank crewmen don't really value data collection analysis as much as real-time data.
Alright, so there's two main parts to our updated MVP. We have first the physical modification of the driver's control and display panel, where we would, in red, you can see that there's ES number 2 and 222 degrees Fahrenheit, which denotes the engine temperature of when the misactivation occurred. That was something that they wanted to know more about, so that when they do talk with the maintainers and notify them of this situation, they can start thinking about, okay, what happened, what did we do, what was the tank really experiencing, so that it would inform the process and kind of speed it up a little bit faster. And then here is our actual product, which is a data collection analysis system, where we would take in these data points and then add it into the system, so that when the system is more mature, you can kind of start considering these factors into determining, okay, yeah, this is the factor that stood out during this misactivation, and then use pattern recognition and trend analysis to start looking into what's really happening. Oh, my bad. Anyways, this is our final mission model canvas. We just kind of started to update it based off of our Germany trip, and then kind of what we will do in the future a little bit.
So let's take a look at a real example. In Germany, during a simulated battle exercise, this particular tank, C-34, had its fire suppression system go off twice, only within a few days apart. And it happened when the crew was checking the dipstick for the oil levels, and then the system popped.
It was not only an inconvenience because the tank took over 24 hours to be retrieved, but had this happened in a real battlefield, the firepower of the platoon would be weakened, leading to more casualties. And when trying to determine the cause of why this went off, we can only have assumptions. This would lead to more resources being wasted by the team as they would just troubleshoot by just guessing and not having an educated guess.
Alright, so there's a little bit of a technical issue, but for our next steps, we are just going to start looking into the mission costs of what is actually happening, and then how much that would actually cost the mission in general. And we would continue looking into our MVP and determining what is more feasible and how we can iron out the details to make sure that everything goes well. And then we would just kind of start developing the technical groundwork for it and kind of get funding more. And then later on, we'll just finally start launching the product and then do more user testing with the end users. And then, so we just wanted to say thank you to everyone here for listening to us and spending time with us. And then thank you to the teaching team for pushing us to do better and continue our journey into this process. Yeah, so thank you for everyone for listening and whatnot.
So, is there one more? We're good for it. So, if you guys remember for the class and for the audience, when we started this course at the beginning of the quarter, the teams have not met anybody. So, we formed a team for them. So, they're working with total strangers, mimicking what it would be like when they graduate and go on to work for companies or start their own corporation or whatnot. So, that was one challenge. Two, the sponsor are wonderful, but they're sometimes difficult to get a hold of, so they have to make a lot of assumptions. And three, as you can see, we have fantastic, super smart students. A lot of them are introverts. So we have to get them out of their comfort zone to say, okay, you need to go talk to this stranger and work with a stranger you never met before. You have no idea who they are, and you gotta do this because we're telling you so. So please celebrate the fact that they've come this far, they've done an amazing job, they've grown in ways that they probably didn't realize, and we are very, very so proud of them. So please give them a big hand. And I would be seriously remiss if I don't thank the support that the team and i4NS teaching team have received over the years. We're on our 5th year. We started out 5 years ago with 2 teams and 8 students in Atkinson Hall in a super small conference room. We're now 5 teams, 30 plus students. We routinely get 85 plus students fighting for 20 spots. But all this is not possible if it wasn't for Tammy. She runs this building, she runs this events for us, so thank you very much, Tammy. And Doug, who's responsible for standing part of 43,000 students on campus. And by the way, we get, I think for this event, 43,000 students, we got 2 bounces and 100% open. So thanks, Doug, for whatever you're putting on the subject line, they're here. It might have been free beer, I don't know, but thanks so much. And Lizos, I don't think she's here, but she's also the person that makes things happen for all of us. So this is the end of our event. Congratulations for the cohort, yay. And please enjoy the rest of the evening. We're up till 7, so please network and do what you can. And one more, sorry, Erica, I'm gonna call you out. So come on up, Erica. So Erica is a alumni, and if you guys don't know, I think you were a speaker for the event. There were mixed signals, right? 2 quarters ago. Was it 2 quarters already? Wow. So they started their own company. They've just been selected for DIE Summer Accelerator Program with living stipend, right? Which is amazing. Erica also was selected for DIU internship starting 16th of June, and she also got a SMART scholarship. So this is all possible for each of you. So you came into this course not knowing what you're going to get. She's one of the success story, and it could be yours as well. So thank you, Erica. Let's see you next quarter in the fall.